Class 9th Polynomial. Today we are going to learn about remainder theorem. To discuss about remainder theorem, we should have the knowledge of some basic concepts. Let us consider two numbers. First one is 6 and 15. We have to divide 15 by 6, which gives us 6 to the 12. By subtracting, we will get 5 minus 2 is equal to 3, 1 minus 1, 0. Here it is clear that 6 is divisor, or we can say divisor, 52 as dividend, 2 as quotient, and 3 as remainder. We can write it as 15 is equal to 6 into 2 plus 3. Let us check it. 15 is equal to 6 into 2 plus 3. 6 2s are 12 plus 3 15. The LHS is equal to RHS. I am going to write it again. 15 is equal to 6 into 2 plus 3 means 15 is dividend. You have seen here 15 is dividend. We can write it as again dividend is equal to 6 here as divisor into 2 is quotient plus 3 is remainder. Again let us take 6 and 12. If we take 6 as divisor and 12 as dividend, then proceeding as 12 is divided by 6, we will get 6 2s are 12. The remainder is, by subtracting, we will get here 0. The remainder is 0. In this case, we do not have any remainder. So we can say 6 is a factor of 12. 12 is a multiple of 6. Recite the table of 6 in which 6 1 jar we get 6, 12, 6 2 jar 12, 6 3 jar 18, 6 4 jar 24. These are multiples. And if we want to get the factors of 6, all those numbers will be the factor of 6 by which 6 is divisible. We get 1, 2, 3 and 6. These are the factors of 6. Thus 6 is the factor of 12 and 12 is a multiple of 6. Now the question is, can we divide one polynomial by another polynomial? To start with, let us try and do this with polynomial 2x to the power 3 plus x square plus x and the monomial x. We can write it as 2x to the power 3 plus x square plus x divided by x, which gives us 2x to the power 3 plus x square plus x whole divided by x. Here x is the LCM of these three terms, so it can be written as 2x to the power 3 upon x plus x square upon x plus x upon x. It can be written as 2x to the power 3 minus 1 plus x to the power 2 minus 1 plus x to the power 1 minus 1. Again we can write it as 2x to the power 2 plus x to the power 1 plus x to the power 0. And we know that x to the power 0 is always equals to 1. So this will be 2x square plus x plus 1. So this polynomial can be written as 2x to the power 3 plus x square plus x is equal to 2x square plus x plus 1 into x. Here this one is multiple of these twos, and these two are called the factors of 2x to the power 3 plus x square plus x. This will be multiple and these will be factors. Thus we can say 2x square plus x plus 1 and x both are the factors of 2x to the power 3 plus x square plus x, and 2x to the power 3 plus x square plus x is a multiple of 2x square plus x plus 1 and x. Let us take the example x plus 3x square minus 1 divided by 1 plus x. Here the dividend and the divisor are not in the standard form, so we have to arrange them in the decreasing order of the degree of variable. Then the dividend will be 3x square plus x minus 1, and the divisor will be x plus 1. We can proceed it as 3x square plus x minus 1 is divided by x plus 1. Here we are going to divide a polynomial of degree 2 by a polynomial that is of degree 1. First of all, we have to see the very first term of the dividend and the first term of the divisor. We have to divide the first term of the dividend, this will be the first term of the dividend, by the first term of the divisor. How can we proceed it? We can do it as 3x square divided by x. This is the rough work. It will give us 3x. This will be 3 into x divided by x. X cancel, and it will give us 3x. Then the first term of quotient will be 3x. We have here the first term of the quotient. We will multiply the divisor x plus 1 by 3x. We will get 3x into x is equal to 3x square. 3x 1 jar 3x plus plus will be plus 3x. By subtracting, this will be minus. It has plus sign, so it will be also minus. 3x square minus 3x square will be cancelled, and here we have 3x of minus and plus x. It will give us minus 2x and here it is minus 1. This will be our remainder. Now we will treat minus 2x minus 1 as a new dividend, and the divisor will be the same as x plus 1. We have to divide the first term of new dividend by the first term of the divisor. We will get minus 2x divided by x is equal to x will be cancelled. Here we will have minus 2. So the new term of quotient will be minus 2. Now with this new term of the quotient, we will multiply the divisor. Minus 2 into plus x will give us minus 2x. Minus 2 into plus 1 will give us minus 2. By subtracting, we will get, by subtracting, the sign will be changed. Plus 2x minus 2x will give us 0, and this is plus 2, and this is minus 1. It will give us 1, and 1 will be the remainder. We cannot divide it again. Thus, the quotient in full is 3x minus 2. The remainder is 1. Dividend is equal to 3x square plus x minus 1. Divisor is x plus 1. Finally, we can write it as 3x square plus x minus 1 is equal to x plus 1 into 3x minus 2 plus remainder 1. This is dividend is equal to divisor into quotient plus remainder. This is the same as we have seen in the case of 15 divided by 6. We have 6 into 2 plus 3, where 15 is dividend, 6 is divisor, 2 is quotient, and 3 is remainder. Here 3x square plus x minus 1 is equal to x plus 1 into 3x minus 2 plus 1, where 3x square plus x minus 1 is dividend, x plus 1 is divisor, 3x minus 2 is quotient, and plus 1 is remainder. Let us take one more example in which we are given the polynomial 3x to the power 4 minus 4x to the power 3 minus 3x minus 1. We have to divide this polynomial by a monomial x minus 1. How can we proceed it? Let us see. By long division method, we have x minus 1. Here we can write this as 3x to the power 4 minus 4x to the power 3 minus 3x minus 1. We have to see the first term here of the dividend and the first term of the divisor. 3x to the power 4 and the first term of the divisor is x. We can write it as 3 into x to the power 4 minus 1 is equal to 3x to the power 3. Then we can say the first term of the quotient of this division is 3x to the power 3. Now with this 3x to the power 3 we have to multiply the whole divisor. 3x to the power 3 into x is equal to 3x to the power 4. We have here sign plus and here minus. So after multiplication we will get the minus sign. 3x to the power 3 ones are 3x to the power 3. By subtracting,
it will be minus and it will be plus.
now 3x to the power 4 minus 3x to the power 4 will be cancelled. The resultant will be 0. Here 3x to the power 3 is of plus sign and 4x to the power 3 is of minus. So the resultant will be minus x to the power 3, and the rest part of the dividend will be as such 3x minus 1. Now minus x to the power 3 minus 3x minus 1 will be the new dividend, while the divisor will be same. The first term of new dividend is minus x to the power 3 and the first term of the divisor is x. We have to divide the first term of the dividend by the first term of the divisor. It will give us minus sign will be remain same, and it will give us x to the power 3 minus 1 is equal to minus x to the power 2. So here we have the new term of quotient as minus x to the power 2. Here minus x to the power 2. By multiplying the divisor, minus x square into plus x will give us minus x to the power 3. This minus and this minus will give us plus sign, and x square ones are x square. Here it will be plus x square. So now we have to subtract. Subtracting, this symbol will be positive and this will be negative. Now plus x to the power 3 and minus x to the power 3 will be cancelled and it will give us the resultant 0, and here we have minus x square. We can write it as a first term because this variable has the maximum power. Minus 3x and minus 1 will remain same. Now this will be our new dividend. We have to see the first term of new dividend and the first term of the divisor. Here it is x in divisor and here it is minus x square in dividend. Then we can solve this as minus x square divided by x. It gives us minus x. Then the new term of the quotient will be minus x. Now we can multiply the divisor by the new term of the quotient, which is minus x. Minus x into x will give us minus x square. Minus x into minus 1 will give us plus x. Now by subtracting, we will get here it will be plus and it will be minus. Plus x square minus x square will be cancelled, and here we have minus 3x minus x is equal to minus 4x minus 1. This will be our new dividend. Again we have minus 4x as the first term of the dividend and x the first term of a divisor. It will give minus 4x upon x will give us minus 4. So the new term of the quotient will be minus 4. Now we have to multiply minus 4 and the divisor, which will give us minus 4 into x is equal to minus 4x, and minus 4 into minus 1 will give us plus minus 4 1 ja 4, or minus into minus will give us plus. So on subtracting we will get this sign will be plus, this will be minus. Here plus 4x and minus 4x will be cancelled, and we will get minus 5 as remainder. In this example, we have divided the polynomial 3x to the power 4 minus 4x to the power 3 minus 3x minus 1 by a monomial x minus 1. We have minus 5 as a remainder and 3x to the power 3 minus x square minus x minus 4 as a quotient. Here the remainder is minus 5. We have x minus 1 as divisor. We have to find the 0 of x minus 1, which will be x minus 1 is equal to 0 and x is equal to 1. Here 1 is a 0 or the root of x minus 1. If we put x is equal to 1, which is a root of the divisor x minus 1, in this dividend, thoroughly we will get 3x to the power 4 minus 4x to the power 3 minus 3x minus 1 will be 3 into 1 to the power 4 minus 4 into 1 to the power 3 minus 3 into 1 minus 1. We will get 3 into 1 to the power 4 will be 1 minus 4 into 1 to the power 3 will be 1 into 1 into 1, which gives us 1 minus 3 minus 1 is equal to 3 ones is 3 minus 4 ones is 4 minus 3 minus 1, which will give us 3 minus 4 and minus 3 and minus 1 will give us minus 8. The answer will be minus 5, which is the remainder. In the long division method, we have seen that minus 5 is the remainder, and here we have the answer as minus 5. This will give the base for our remainder theorem. You have noticed that x minus 1 is divisor 3x to the power 4 minus 4x to the power 3 minus 3x minus 1 is dividend. The root of x minus 1 is 1. Let px is equal to this dividend 3x to the power 4 minus 4x to the power 3 minus 3x minus 1. We have to divide px by x minus 1, which has 1 as its root. If we put in this dividend x is equal to 1, we will get p1 by putting x is equal to 1, 3 into 1 to the power 4 minus 4 into 1 to the power 3 minus 3 into 1 minus 1. We will get 3 minus 4 minus 3 minus 1 is equal to 3 minus 8, which will give us minus 5. We can say if any polynomial of degree greater than or equal to 1 and let a be any real number, the polynomial is divided by the linear polynomial x minus a, then the remainder is pa. As we have seen in the case of earlier example, x minus 1 was monomial which has a is equal to 1 and a as its root, and 3x to the power 4 minus 4x to the power 3 minus 3x minus 1 as a polynomial of degree greater than or equal to 1. Here the degree is of 4 and let a be any real number. A is equal to 1 which is a real number. Then if we divide this polynomial by this divisor, we will get the remainder as
PA.
any polynomial of degree polynomial, let us take it as px, of degree greater than or equal to 1 and let a be any real number. If the polynomial is divided by the linear polynomial x minus a which is divisor, then the remainder is pa. Here in this example, px as 3x to the power 4 minus 4x to the power 3 minus 3x minus 1 and divisor is x minus 1 in which 1 is a real number. So according to this theorem, which is remainder theorem, if we put x is equal to 1 overall in this polynomial, we will get the remainder which is minus 5. Here by putting x is equal to 1, we have 3 into 1 to the power 4 minus 4 into x 1 to the power 3 minus 3 into 1 minus 1, which gives us at last minus 5 as the remainder.
This is all about the remainder theorem.